Now then, for solving the three variable systems, the method that we're going to look at is what is a method that utilizes what are called matrices. Now, it is plausible to do three variable systems using other techniques such as substitution or elimination, but we are going to be looking at using matrices. Now, the first thing that we're going to talk about is what's called an augmented matrix, and I'm actually going to build and show you how to build an augmented matrix, and then we'll talk about the goal for how this is going to go. So, you're going to start with your system. Okay, and what you're going to do is you're going to have, you use kind of a large square brace. And so we're going to have three rows here, and we're basically going to line our things up x's, y's, and z's. So we do want to have our equations set up where we have x's, y's, and z's in that order, our equal sign, and then our constant. So the only thing though that we're going to need to take are our coefficients. So I have 1x, a -2 for my y, and a +3 for my z, and then I'm going to have this vertical bar, and that's going to indicate where my equal sign is. And then I have 22. And so for my next one, I have 2x's, -3y's, -1z. So 2x's, -3y's, -1z, and it equals 5. And then for my last equation, I've got 3x's, 1y, -5 on my z, and I have -32. Going to close that off. So I end up with something that looks like this. Now, the reason it's called an augmented matrix is because we have this extra column out here. Normally, we consider matrices that are what are called square, so they have the same number of rows and columns. This would be a 3x3. An augmented matrix has this extra column out here that has our answer solution in there. Okay, so now the goal, okay, is for us to take that matrix and to make it look like this. And I don't have that pure vertical line right up there, but the goal is I want to have ones on that main diagonal, and I want to have zeros in that bottom quarter. And the reason that I want to have this is because this very, very bottom line of my equation now says no x's, no y's, z. So this would be 1z. Remember, this is our equal sign, and then this is going to be a value. So I'm going to have z equals some number. Then if I read the line right before it, I have no x's, y, and some like 2z or -4z or something like that equals a number. But I can solve that equation by replacing the value of z that I got from this one into this, and I can solve for y. And then I can plug both of those back into the top equation in order to get the output. So here are another couple of examples. Okay, so here we see a system. This would then be built into this augmented matrix. This solution matrix, notice the one on the diagonal, so the 0 in the bottom corner, would actually be how we were going to come about coming backwards. So notice at the bottom one, we have z equals 4 because I have no x's, no y's, z equals 4. The previous line, I have no x's, 1y, and 3 z's equals 9. So I have y plus 3z equals 9. Now, in order, I can solve that for y by plugging in z as 4. So then I would have y plus 3 times 4 equals 9, and I can solve that for y. Once I have those two values, I have 1x plus 2y minus 5z equals -19. Again, I would have a value of z equals 4. I would determine the value of y here. I could plug the y value and the z value in, and then I can solve for x, be able to find solutions for this.